Hello everyone, so today we're going to go over section 5.1, defining conic sections. So a conic section is a curve obtained as the intersection of the surface of a double nap cone with a plane. So as we can see here in diagrams, we have a plane and two cones that are connected at a single point. So each one of these cones is called nap. Oops, sorry about that. And in this case, the curve that is formed from the intersection right here is a parabola. The singular point that connects the two naps is called the vertex. Okay. So each nap has a base, which is right here. And the line, which is perpendicular to the base and goes through the vertex, is called the axis of the double nap cone. So right here we have the axis. And in the second diagram, we have two more conic sections. Here we have this shape, which is an ellipse. And here we have a circle. The two sides of the cone from this cross section that we see, they are called the generators of the double nap cone. And we have a fourth type of conic section here with two parts, and including both parts in the definition, we have what's called a hyperbola. Okay, so once again, that is the parabola, the ellipse, the circle, and the hyperbola are our four conic sections. Although the circle is just a special case of the ellipse, we usually refer it to as four different shapes. Okay, so first let's look at the parabola in greater detail. When the intersecting plane is parallel to a generator on the cone, then the intersection will be a parabola. So in this case, we have the generator going this way, and the plane, as we can see, is parallel. So the resultant conic section is a parabola. And of course, the parabola has a very familiar equation right here in vertex form. Or in general form, we have y equals ax squared plus bx plus c. Okay, so that is the parabola. Next, we have the ellipse. So when the intersecting plane is inclined to the base, the curve is an ellipse. And the incline is somewhere between being parallel to the generator, which causes a parabola to happen, and being parallel to the base, which is a special case of the ellipse, a circle. So that is, once again, between being parallel to a generator and being parallel to the base. So if it's somewhere between those two, then we have, once again, an ellipse. So we have, in one case, a parabola, and then in the other case, we have the circle. So, one more note about the circle, which is, of course, the next conic that we're going to look at, is that its equation is x squared plus y squared equals r squared. Again, we're going to assume that the circle is centered at 0, 0, and the radius will then be r. And the idea here is that the center of the circle can be translated by applying transformations very similar to those that we have seen with functions. Okay. The last one is the hyperbola. When the plane intersects both naps of the cone, the curve of intersection is a hyperbola. Okay. Another way to thinking about this is that it passes through both naps, but does not pass through the vertex. In this unit, we'll also be looking at the equations for the hyperbola and also the ellipse. We have already seen those for the parabola and also the circle. So that's it, just a short introduction to the 4 different conic sections that we'll be looking at. Once again, the circle is a special case of an ellipse, and that's it for today. So once again, thank you for listening.